Hello. In this module, we'll be talking about the multiplicative rule for the calculation of the probability. Before we go further, we need to review the two definitions of independent event and dependent event. Independent events are those events that do not have any effect on the occurrence of each other, whereas two events A and B are said to be dependent events if for the occurrence of A, B has its impact. So when there is an impact, the events are said to be dependent, and when there is no impact, the events are going to be called as independent events. So we use the multiplicative rule to calculate the probabilities of two events which are occurring at the same time. Let's say there are two events, A and E. And we already know the definitions of A and E. The multiplicative rule is a way to calculate the probability that the event A and E both occurs at the same time. Therefore, it talks about the joint occurrence of two events. And since we already know that AND operator is this intersection operator, so therefore, the probability for the joint occurrence of the events A and E will be given as probability of A intersection E. There are two rules within multiplicative rule. The first rule is a more general rule which is used to describe the dependent events, whereas it has another specific rule that talks about only for the independent events. So let's say if two events are dependent upon each other, then the probability of their joint occurrence will be equals to the product of the marginal probability and the their respective appropriate conditional probabilities. And whereas if two events are independent, the probability of their joint occurrence will just simply be the product of their marginal probabilities, which is given by probability of A intersection E is equals to the probability of A multiplied by the probability of E. Let's take this example where we have been studying the effect of the family history of mood disorder on the onset of the bipolar disease. Here, if we already know that probability of A given E is 0.1986 and probability for the early onset, which is probability of E, is given by 0.4434. If we wish to compute the joint probability of early age onset and negative family history of mood disorder, that is A, from knowledge of an appropriate marginal probability, which we already have, and appropriate conditional probability, we are able to calculate their joint probability, which is given by the product of the marginal probability and the conditional probability. It is given as probability of A intersection E equals to the probability of A multiplied by the probability of A given E. The values are 0.4434 for the early onset and the probability of having no history of mood disorders, given that there is an early age onset. It turned out to be 0.1986. And if we are interested in finding the joint probability, it will simply be the product of this marginal and this conditional probability, which turn out to be 0.0881. There is the specific multiplicative rule of the probability, which states that for any two independent events, A and E, the probability for the joint occurrence of both A and E is a product of their individual probabilities, and that's specifically we talked earlier. In general, one can think of the multiplicative rule as AND rule. If both events A and E must happen in order for a certain outcome to occur, and if A and E are independent of each other, then one can use specific multiplicative rule to calculate the probability for an outcome. In all this discussion, the key word is that A and E are independent events. So let's take an example that there is a cross between two heterozygous individuals, and we are interested in finding out the probability for a homozygous individual with traits A and small a individual in the next generation. The only way to get this offspring is that mother contributes the A gamete and the father contributes the small a gamete. Each parent has half chances of making an small a gamete, which is the recessive gene. Thus, the chances of AA offspring is given by the joint occurrence of the probability from both. And from here we know that, let's say that an event A refers that a mother contributes small a gamete and a father attributes small a gamete is represented by an event B. Then the probability for the joint occurrence will be given as probability of A intersection B, which is given by 1 by 2 multiplied by 1 by 2 equals 1 by 4. The reason we are just taking the product of these two events is that event A and B both are independent events, and there is no dependence between getting A from the father and A from the mother. Let's look at this Punnett square. From here, we can see that all possibilities are 4 different possibilities that are the outcome of this cross. Over here, there are half the chances for a mother to give small a. And there are also half the chances of getting small a from the father. And if we look at all these 4 squares, there's only one event that could possibly occur. So with AA characteristics, so then the chance of the occurrence of both events is 1 by 4. We see through the algebraic manipulation of the multiplicative rule stated earlier that it may be used to find any one of the 3 categories if we know 2 of them. Thank you.